All right, ladies and gentlemen, today we're going to start Unit 6, Lesson 6-1, and we're going to understand area. Now, I've went ahead and ripped these pages out because I've ripped out pages 201, and of course on the back of that it's 202 and 203, and on the back of that's 204. So I've went ahead and ripped these out. We're going to understand area. Which one of these does not belong? Think about it. I know what I think, because this is just to get you engaged. There's really not a right or wrong question. All right. I can say that this one I see patterns in. The same shape is over and over. This one I see the same shape over and over. And this one I see the same shape over and over. But this one, they're not the same shapes. They're every different which way, right? So I could see that. I can see the lines in this one and the lines in this one. Of course, this one's circular, isn't it? And this one, there's no lines or anything anywhere. So there's a lot of different things. I can see color, and I can see color in these two. Really don't have a lot of color. This is different shades of brown, and this is black and white. So there's some different things. We're going to connect area and multiplication. So I'll flip the paper over, and so now I'm on page 202. I'm on page 202, and we're going to learn. Grayson will cover a bulletin board with square sheets of paper. He wants to use the fewest sheets without any gaps or overlaps. So he cannot overlap it, and he can't leave it as gaps where there's space in between. How can Grayson determine the number of sheets he will need? So the unit of this is 1 and 1. You can place square units, and that's going to be a vocabulary word, square units, on a figure without gaps or overlaps. This is called tiling. So this is a square unit because it's square. It's 1 by 1, so it's perfectly square. So do you see how they're lined up? They're not overlapping, and there's no gaps in between there. Count the unit squares that cover the figure. So if I cover the figure, then that's 1 unit square, 2, 3, 4, and so on. We also can see this as an array because there's 3 by 5, so 3 times 5 is 15. Grayson will need 15 sheets to cover the bulletin board. Oh, here's that wonderful word, area. Some of you all have been asking about this. So the area, because we're covering the bulletin board, we're covering the area of that bulletin board. That's the reason it's called area. The same thing with an area rug. It covers a certain amount. Is the amount of surface inside a figure. You can find the area of a figure by tiling it. The area of the bulletin board is 15 square units because they're square units. You can find the area of a figure by tiling and then counting the number of squares that you covered in the figure. How can you find the area of this figure? So look at this, and this is a square unit. So if I extend this line on out here, and I drew it down here, now I'd have to draw another one right there, wouldn't I? I could find how many square units it took to cover it. 1, 2, 3, 4, 5, 6, 7, 8. So I just drew how it would be. Some people can look at this and say, well, this is 2, so 2, 4, 6, 8. They might count by 2s because of our arrays. So I can divide the shape into square units. There we go. That's how I would do it. Now go ahead and flip that paper over. Or actually, that's not flipping over. I'm going to put that one underneath of it so I don't lose it. And I'm going to be on page 203 now. 203. Which figure is tiled correctly to find the area? Circle it. Now remember what we said. Do you see this gap? See these gaps? These gaps can't happen. If you're tiling an area, you cannot have that. It has to not have any gaps. So therefore, this is the correct one. All right. What is the area of the figure? Draw to complete the tiling. All right. So you're going to have to draw. So I'm going to extend these lines. Now I'm not going to go fast. I'm going to extend these lines straight down. And then I'm going to extend the lines straight over. And after I have that, I can count to see how many there is. So 1, 2, 3, 4, 5, 6. There's 6 in a row, and there's 1, 2, 3. So there's 3 and 6. So 3 times 6 I know is 18 square units. Or I could keep counting. Now if I extend this going down, like that, and I extend this one coming over, so I've got 1, 2, 3, 4. I've got 4 up here in this area, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in this area, so 4 and 12 is 16. Or I can count each one of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Or I could even write the numbers in there if I want to. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can do any of those. All right, I've got to find the area of this, so I'm going to go ahead and extend it. Extend it. And I'm going to drop, that one's a little too big. Down, down, down. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, look what they've taken away from us. We've got 24, but did we put the unit? We did. They didn't. So we've got to write down square unit. All right. Now, I know I can cut that one off. Extend this line on out. Extend this line on out. Extend this line down and extend this line down. Now I can count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I've got 18, but I'm not done by just putting 18. I have to put square, SQUARE, square unit. All right. Why is it important that there are no gaps or overlaps when tiling a figure? Well, it's important because if I had this shape, let's think about this. If I had this shape and I want to say, oh, well, it's 3. Well, let's look at that. So it's 5. Is that really how long it is? That's like saying that if you measure the stick, it's 1 inch, when it's not, especially if the stick's like this and you go, oh, it's 1 inch, because an adult pinky is close to 1 inch. So that's 1 inch. Now, if I went 1 inch, 2 inches, that's not going to be good either. You've got to cover the whole amount to be able to do that. So, why is it important that there are no gaps or overlays in tiling a figure? It is important, and I'm using the word important right there. Important, because you are completing a measurement. If you're tiling the floor, you need to know how many tiles to cover the area at which the floor is. If you're putting carpet over it, you don't want to have just part of it covered. You want to cover the whole area. Label the length of each side of a square unit. 1 and 1. That's a square unit. 1 and 1. All right. 2. Flip it over and look at the back. 8. Area equals 20 square units. So we've got to divide this up to 20 square units. Well, I know what I would do, because this is just me thinking. If I go 5, 10, 15, 20, right? So if I did 4 rows of 5, 1, 2, 3, 4, and then went 1, 2, 3, 4, 5. Now these are really hard. Is this square the same as this? No, but that's what we're trying to do, but we're not measuring, getting out our rulers and marking it off. We may later on, but not right now. All right. Area equals 18 square units. See how this one's longer? So if I cut this into 3 lines, what would I have to have here? 3 times blank equals 18. What does that need to be? How many 3s will it take you to get to 18? Well, I know 3 times 5 is 15. So I would need another 3 times 1, which is 3. And so that would be 18. So I would have to have 6. So 1, 2, 3, 4, 5, 6. Now, this is stuff that we've learned before in math class. This is just going back and reviewing it. All right, let's look at 10. Sam designs a doghouse. He plans to cover the floor with a mat and will need to know the area. How can you tile the figure below to find the area of the doghouse floor? I'm going to read it again. Sam designs a doghouse. He plans to cover the floor, so he's wanting to cover this floor, with a mat, and will need to know the area. How can you tile the figure below to find the area? If this is 2 units, that means I would have to cut it this way. And if this is 3 units, that means I would have to cut it this way, because there's 3 units going this way and 2 units going down. And that means it's a total of 6 units. So the equation can be 2 times 3 equals 6 units. actually square